Okay, hello dears. Today we will study momentum. It's Tuesday, 17th of March. You can find everything about momentum in pages 17 to 19. بدك إشي عبود؟ اوكي خلص اوكي خليه طافي عشان انا اقدر انتبه. المشكلة اذا ما دخلت. خلينا نشوف. خلص عادي. اوكي طيب يا جماعة let's define moment. أول شيء what is meant by moment. نقول moment ما بفضل إذا بدكم تكتبوا معي بس بسرعة مش راح أستنى لأنه بس إذا بدكم هذا راح يضل ريكوردد على يوتيوب فبتقدروا تاخذوه later on من يوتيوب. أظن هيك واضح على يوتيوب. أوكي moment بنقول is a measure for the turning effect. The turning effect of a force. This is not the definition because if I ask you to define, you need to do it. The idea is just we want this is I want you to understand what do we mean by moment. Let's see if this object is here and I push it by certain force like this. Will the object, what will happen for the object? يعني I believe everybody knows that it will move to the side, right? Since it moved to the side, then not rotating, it's not turning. But this force has no moment. So the moment is important when there is a rotation. Now, what will happen if I have a rope connected to this box and I just push it by this force? What will happen for the block? I believe it will turn even a little bit, not necessarily to be full cycle, but it will turn. Now, this force has a moment because it was able to turn the object. So the moment is a measure for the turning effect of a force. Okay. Wait a second, let me check with Mah. I'm trying to join the group. Okay, last please. أنا ما شفت إنه مها بدها تدخل. اوكي معلش تحملونا بس لأول مرة مش الموضوع مش كتير سهل على الكل عم بنحاول نرتب الأمور. خلينا أدلها نقول try from your mobile. Okay. Sorry يا جماعة أخرت عليكم. طيب. Now this is the meaning of moment. I wish that it's simple. So moment is a measure of the turning effect of a force. Now, if I'm asking you to define moment, you don't mention this. This is just only for understanding. Even if I'm asking you what is meant by moment, you don't mention this. Like I said, you have to define it as the following. You know, moment, definition. Equal, as we said, any definition you just put force times. Now force times distance, but which distance should we go? It's the perpendicular perpendicular distance between the force and the point of rotation. احنا in O level we called it the pivot, not necessarily to be pivot, but yes. So moment equal force times distance, M equal F times D, but it's not enough to mention distance, you have to write perpendicular distance between the force and the point of rotation. Now, I will explain what do you mean by this, but let's write the units first. Moment and force is in a Newton, distance is in meter, so here it is a Newton times meter, so we call it Newton meter or Newton dot meter. This is the unit for moment. Now, let me explain what do you mean by the perpendicular distance. Here, if anything not clear, please stop me. Here in my example, when I had this box here and I pushed it by this force, what will happen for it? It will rotate. But if I want to know what is the distance, moment equal force times distance. Which distance? The distance between the force from here to the point of rotation. It is rotating around this point. So which distance does you want? I want this distance. But Ustaz, this distance is not 90 degrees. Yes, because it's not 90 degrees. We either take this distance from here to here, which is 90 degrees, or I will show you another way how we will use resolving to find the distance. I will take another example. So this is simple. Let me show you another example for moment. هلا انا لايف على يوتيوب موجود. في 3 people are watching بعرفش مين هم. Okay. اوكي لانه it will be recorded, it will stay there. هلا الميتنج هذا ما فيه recording بس هذاك فيه recording. Okay. Yeah. So let's say another example. Let's say here I have a block and I want to lift it up by force like this at an angle theta, and here is the hinge or the pivot where it rotates, so this will move up as you push it up. So if I'm asking you calculate the moment equal force times distance, which distance Ustaz between the force and the pivot? This is the distance. But this distance is not 90 degrees to the force. So what do? We have to make simple resolving. As we said, here we have F horizontal, here we have F vertical. Now, F horizontal is F cosine theta, F vertical is F sine theta. So here, if I want to find the moment, I have to find force times distance. Which force is 90 degrees to the distance? F vertical. So here, it should be the vertical force. But Ustaz, the vertical force is F sine theta. So is it okay to write it this way? So moment in general equal force times distance times sine theta. In O level, we did not study this equation because all the questions that we took them, the force was already 90 degrees. Sine 90 is 1, so it cancels out. Now here, it could be any other angle. So if there is an angle, we just use this equation. So I need you to memorize this equation. Is it هذا memorize it? Ustaz, mish moment is given. Yes, they give you this equation. They will give you moment equal force times distance. This is given, but you need to know that we can't use force times distance unless if they are 90 degrees. If they are not 90 degrees, We just use force times distance times sine theta. Okay? طيب. Second point. Now, moment, is it a scalar or vector? Is a vector is a vector quantity. So it has direction. What is its direction? Always direction of rotation is either clockwise or anti-clockwise. So its direction is either clockwise or anti-clockwise. Remember, I'm not saying the direction of the force is clockwise. I'm saying the direction of the moment is clockwise or anti-clockwise. The force is east, is west, is 30 degrees to the horizontal, 40 degrees with the vertical, whatever it is. But it's never clockwise or anti-clockwise. The force is not clockwise or anti-clockwise. The force is straight. The angle is the moment is the clockwise or anti-clockwise. So moment equal moment is equal to force times distance sine theta, and its direction is either clockwise or anti-clockwise. How can I tell you? Have to imagine it. Imagine it. Now I have this object here. Let's say this is the rod. Here it's the hinge. Now you are pulling it this way. So is it rotating clockwise or anti-clockwise? It's opposite to the clock, so anti-clockwise. So this direction is anti-clockwise. This direction is clockwise. So I think now it's clear. Now let me give you some examples to see how do we do with moment. Now, if you remember, when we talked about moment in O11, we said that moment exists in so many cases in our life. For example, when you are opening a door or you're closing it, you are using the door handle to open the door or closing it. If you are opening a Pepsi can or bottle of water, if you are using the tap, water tap, opening this way or this way, your body is full of moment, so moment exists everywhere in our life. Now, let me take this example. Let's say this is door handle, and here is the point of rotation, and we have Muhammad is trying to push this handle by force like this. Now this force, if I'm asking you calculate the moment, well, moment equal force times distance. Which distance? This distance. Abu says, do I need to put sine the angle? In fact, you don't need, because it's 90 degrees. If you put it sine 90, it's 1, so I will cancel it. So like this, yes, there is a moment. Example number 1. Now, example number 2. What will happen if you, the same handle, but now you apply the force at this point, and this force is same as this force. If this force is the same as this force, then the moment here is less. It is reduced. ليش؟ لأنه the distance becomes less. So, like this, either it will not rotate, or maybe for rotation you need bigger force to produce the same moment as before. Now, example number 3. What will happen if I put my force over here? Now, moment is equal to 0. Why? Because there is no distance. The force is acting on the pivot. When the force is acting on the pivot, there will be no distance. Last thing, what if I apply the force like this? Again, Ustaz, it will not rotate. Why? Because it's parallel. Type. calculate the moment, we know moment equal force times distance times sine the angle. Which distance? This distance. So there is a distance, yes. But what is the angle between the force and the distance? The angle is either 0 or 180 degrees. Sine 0 or sine 180 degrees is 0, so it cancels out. 0 multiplied by anything, so here there is no moment. This is just only introduction to understand what do we mean by moment and how to deal with it. Remember, this case is important. Here we don't say there is no force, we say there is no moment, there is no rotation. There is a force. So when I'm asking you calculate the resultant force, yes, there is a force. So you take it into consideration. But if I'm asking you calculate the resultant moment, then this force has no moment. Moment equal to 0 because there's no distance. Also here, there is no moment. There is a force, but there is no moment. So this force and these two forces are taken into consideration when we are calculating the resultant force, but not when we are calculating the resultant moment. Okay. Now, I want to take what we called it in O level. We said, what are the conditions for an object to be in equilibrium? Conditions for equilibrium. What are the conditions? No, there are two conditions to be in equilibrium. You will find this question in the past paper, but in the past paper, moment was not included. So if you go to the mark scheme, they will say only the first condition, resultant force is 0. But since 2018, this is not an enough answer. Even if you find it in the past paper was enough, now it's not enough because there is another condition. First, let me explain this condition. Resultant force equals 0. What does this mean? This means forces are balanced. So many times I ask the students, what do we mean by resultant force equals 0? They say forces are equal. It's a wrong answer. Forces are balanced. This is the meaning of resultant force equals 0. Remember, there is no question in the universe with no resultant with no force, but there is so many objects with no resultant force. So no force is wrong statement, but no resultant force possible, which means there are forces, but they are balanced. So this is the first condition to be in equilibrium. So if you want to check if this object is in equilibrium or not, check first the resultant force. If resultant force is 0, it's not enough. Check the second condition. What is the second condition? Resultant moment is equal also to 0. This is what we call it principle of moments. Principle of moment. If I'm asking you what's the principle of moments, you say, in case of equilibrium, this has one mark, you have to mention. Then the resultant moment of a system around a point, any point, is equal to 0. So this is what do we mean by principle of moment. So resultant moment should equal 0. What does this mean? The resultant force equals 0 means forces are balanced. Resultant moment equals 0. What does this mean? It means that the total clockwise moment must equal to the total anti-clockwise moment. Okay? Okay. I think this is simple. but application of this, it may be a little bit tough. Let's say one of the questions there. Remember with me يا جماعة في عنا شيء اسمه center of gravity. I said it before in the worksheet previously on center of gravity means it's a point where all the weight of the object is assumed to act upon that point. موجودة هناك. If you did not find it, you may repeat this and write it just after me. I don't want to write it. But remember, the weight acting from the center of the gravity. So all the forces are measured and distances are measured from the center of gravity. So let's take question 1. نقول a uniform rod. What do you mean by uniform? I will tell you. Of weight equal 150 Newton and length is 4.0 meter is supported by two supports, A and B, as shown on diagram. So here, this is the rod. It is uniform, so the weight is at the center. Since its length is 4 meters, so if this is 4, so at 2 meter, here we have the weight, 150 Newton. This is the weight of the rod. It is supported by two supports, A and B. Where are these two supports? I want to draw them here. Let's say this is support A, this is support B. Now the distance from here to here, let's say it's half a meter. The distance from here to here is half a meter. So the remaining from here to here is 1.5 meter, and the remaining is 1.5 meter. Usually they don't give you all of these. You have to figure out this distance is on your own depending on the information given. So this is 4 meters. Half meter, 1.5, 1.5, half meter. If I'm asking you, what are the forces acting on this rod? Please, anybody remove the mute and answer me. What are the forces acting? If I'm asking you, draw the free body force diagram of the rod. What are the forces there? Except weight. What else? What do we have? Can anybody answer me? Yes, normal reaction. But how many normal reactions do we have? 2. So here there is reaction at point A. I want to call it RA. Here there is normal reaction at point B. And in this case, since everything is symmetric, then this is 75, this is 75. Why? Because the rod is at rest, so it is in equilibrium. If it was in equilibrium, this means the resultant force equals 0. So forces up equal forces down, and it's not rotating. So surely total momentum also will be 0. Total moment, sorry. So here, the two forces will be equal. Now, let's continue our question. We did not finish our question. Okay. A student of weight equal 450 Newton is standing at 0.5 meter to the right of support A. Now, here there is a boy, student, his weight is 450 Newton. طبعا I say boy because 450 is a young child, young kid there, 450. He is standing at half meter to the right of point A. Now, what do you want to start? Find RA and RB. Now, RA and RB are not equal because they are not symmetric. RA, surely it is greater than RB because it has more weight at this side. So, find RA and RB. Question like that, it may has at least 4 marks. And maybe if it was in the moment in M1 in math next year, maybe it will be more than 5 marks. So now it is simple. It's nice that I'm teaching you and it's raining outside. Okay, don't look outside. Okay. Now find RA and RB. In math, we learned that if there are 2 unknowns, then we need 2 equations. You have to find the 2 equations. From where I can get the 2 equations, Ustaz, you say from the 2 conditions of equilibrium. The first condition of equilibrium, it was saying resultant force equals 0. So I need to erase all of this, and I'll put again the drawing up. It will help me to explain the question. Okay, so this is A, this is B. Let me put the forces. We said here we have R A, here R B. Here I have 150 Newton, which represents the weight of the boy. Here we have 150 Newton, which represents the weight of the rod itself. The distance from here to here is half a meter. From here to here is half a meter. So what is remaining here is only 1 meter. Here it's 1.5 meter, and here it's half a meter. Now, as we said, since the resultant force is equal to 0, then this means RA plus RB is equal to 450 plus 150. So RA plus RB is equal to 600. This is equation number 1. So it's simple. Just tell me what is RA. I can find what is RB. So if RA is, let's say 300, then RB is 300. RA is 400, then this is 200. It's simple. Now, how can I find one of them? I will use the other condition for equilibrium, which is resultant moment must equal to 0. So, Ustaz, do you remember how did we do this in O level? In O level, we were saying, it's just simple. Force and distance equal force and distance. F1 D1 equal F2 D2. Okay, where is the pivot? Ustaz, there are 2 pivots here. So what should I do? Listen to me. You don't need to take the pivot at here or here. You can take the pivot anywhere. Let's say I want to take the pivot at this point. Can I? Yes. How? I will show you later on this. Can I take it at this point? Yes. Can I take this point? Yes. Can I choose it here in the middle? Anywhere. You can take the pivot everywhere. So the pivot is not A or not B. It's not point A. It's not point B. You can figure out, you can choose whatever you want. My advice is always to choose the pivot, either A or B. Why? Because you want to find RA or RB. So if you say take moment around A, then RA will have no moment. It will cancel out the moment, not the force. The moment will cancel out. If you take it at B, then RB cancels. If you take it at the weight, then the weight cancels. If you wait at the student, the weight student cancels. If you take it here, none of the forces will be cancelled. I will solve it later on to take the moment here. But let's say the moment is at point A. So yeah, I prefer to write like this even in the examples to explain for the examiner what you are doing, because there is no one way of solving this. There are many solutions. If you mess with something, maybe he will not understand what did you do. So it's better to be clear. So here I will write take moment around A. This means consider A to be the pivot, okay? So this means RA has no moment, no force, no moment, because as we said in example number 3, if the force acting on the pivot and I now consider this is a pivot, they will cancel out. The force will cancel, the moment will cancel. So here, A will have no moment. What are the rest? What are the forces that we have there? We have 1, 2, 3 forces. So we have 3 moments. What are the 3 moments? We have 450, 150, and the moment produced by B. Since moment clockwise should equal moment anti-clockwise, we don't care which is clockwise, which is anti-clockwise, we care which 2 forces produces the same moment. These 2 produce the same moment. In fact, these 2 are clockwise because this is the pivot. So this is clockwise, this is clockwise. So moment clockwise equal moment anti-clockwise. So 450 multiplied by the distance. Which distance, please? Pay attention. The distance from the pivot to the force. We said this is the pivot, this is the force. The distance is half. Okay, this is moment number 1 plus, because this moment also in the same direction, 150 times the distance from here to here. So how much the distance? 1.5. Should equal all of these 2 produces clockwise moment. So these 2 equal to the moment of the third force, which is RB, multiplied by what? Multiplied by all of this distance. How much is this? This is 1.5, half. This is 2, and 1, 3. So 3 meters. Now, I don't have my calculator. I need you to do this with me on calculator. This is 450 times half. It's 225 plus 75. So it's 300 equal RB times 3. Please correct me if I am wrong. I did my calculation with my mental math. So RB equal 100 Newton. Do you agree with me, Asad? صح؟ أسد حبيبي؟ شكله راح يشرب قهوة يا أسد. إيش يا عبد؟ كويس صح؟ ظبطت الكالكوليشن؟ طيب ممتاز. Okay, this is RB. So now I want RA. هلا بنقول RA plus 100 equal to 600, right? So RA plus, so RA is 500 Newton. So these are the 2 answers for this question. It is simple. 150. Did you put here 3, Habibi Abed? Is this 3? 1.5 and 1.5, it's 3 meters, huh? This is 75. شو رأيك يا عبد؟ شو رأيكم يا جماعة؟ شافعي أنا بعتمد عليك في الكالكوليشن. 1.5 هاي مش هاف. صح يا بي عبد الرحمن انك مصحصح. Okay, tell me what's the answer here, عبد? لا, this one شو بيطلع؟ 450. عبد? So now this is 150. Okay, I agree with you. Now انا سالتك قلت لي يا معلم شو. طيب اذا هنا 450 نيوتن This is RA. Okay. كنا راح نكتشف انه غلط لانه I want to solve it again by a different method. هلا if you are writing with me it's good. I want to write another solution. I prefer not to write it, okay? If you want to just keep it there, you can. If you want to take a photocopy of the other solution, but it's up to you. This is the same. I want to erase this. I want to take another point, not A the moment, but I want to take about any other point, and I will show you that I still get the same answer. This is very easy. But I will show you another method. أبو نبع وأحمد مركزين معي حبايبي؟ أحمد ممتاز ممتاز. ما معنا بس على اليوتيوب، مش عارف إذا هو لايف 100% ولا كأنه فيه شوية ليت هيك حكوا لي، مش عارف، إن شاء الله تكون قادر تركز معنا. طيب. Now or take moment around. I want to take the moment around the edge, this edge. Around that edge, and I'll draw X here. Okay? You see? Yes. You will get the same answer. But it will be longer. So that method is easier. Okay. Now remember, this is the same. There's no change. Up equal down. Okay. Now, the moment around this point, how many forces do we have? 1, 2, 3, 4. None of them we have cancelled its moment, so we will take them all because I take the moment around this point. This is the pivot. So, force 1, RA, times the distance is half, plus RB, times the distance. وهذا كله 4, cancel half is in 3.5. Should equal this force 450 multiplied by this distance from here to here. It's half and half. The distance is 1 plus 150 times all of this distance. All of this distance, because this is the pivot. It's 1, 1.5, 2. Now this is 300 plus 450. So this is 750. خليكم صحصحين معي. Calculation على مسؤوليتكم. صح؟ Equal half RA plus 3.5 RB. Now here I have one equation. Here is the other equation, equation number 2. Now we can solve them simultaneously. You will find the answer is the same. If you want to see, let's try. Let's multiply all of this by 2. ليش؟ نخلص من half. Just to ignore the half. وبصير RA plus 7RB is equal to 1,500. And put this one here. RA plus RB equal to 600. Let's do subtraction. Minus. Subtract. This minus this 900. 7 minus 6 RB. These cancel. So RB is 900 over 6. 900 over 6 is 150, as what we found it before. مظبوط؟ مظبوط يا جماعة؟ حدا يجاوبني please. Am I doing it right? ممتاز. شايفين؟ إذا هي another method. I don't advise you this method. هاي مشكلتها مع المومنت إنه it has many ways to be solved. But it's okay. You can do it this way. وبرضه كمان it will work. Okay? طيب. What do you want to do now? This is example number 1. Now, I want to solve, to show you another example. Okay. Let me keep it on the same example. Let me put it part B. uh, how many meters can this student walk before tilting the rod? What do you mean by this, Ustaz? Now, imagine that there is a rod and you are standing on it. Here, you are trying to balance, okay? There are two supports here. Just as the question, the same question, okay? I did not change the question. This is A, this is B. Here there was the student 450 Newton. This was the weight of the rod, 150. Now when the boy was here, this was 450 Newton and this was 150 Newton. Now he starts walking, check, 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 check. As he's going to here, it may not flip because these two will be chained. But if he moves to this side, 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 maybe when he reached to a certain point, maybe it will be flipping. So how many meters he can walk to the left? Now he may walk to the right and reaches here and also tilt. Tilt means about to fall. Okay. So how many meters can this student walk to the left? To the left, right? To the left, to the left. How many meters he can walk to the left? He is here. This distance is half meter. How many meters he can walk before the rod tilts, before he falls down? That, if he's walking to this point, imagine with me. Let's say there is a rod here. I am moving, and I reach here. It may flip, right? Then it's my weight here is heavier. So if it flips like this, then the force here will become zero. When I tell you tilting about point A, then this means point B has no reaction. So this is RA, this is RB. So since it tilts about A, then reaction at B is equal to no normal reaction. It's not in contact with it. It will be tilting about this point. So there will be no reaction at this point. So this information, we can understand it from the word tilting, but you have to decide it's tilting toward A or toward B. Depends on the question. I said to the left, so it's tilting about A, so it's balancing on A, so B will lose contact and it will become like this. So this means, RA plus 0 equals 600. I did not ask you to find RB. I want to find the distance, but we need to know what is the reaction at A will be there when it is tilting. So this is the first part of the solution to know what is the reaction there. The reaction there is 600. Okay. This is first. Second, now what do you want to do? I want to erase, and I want to raise it up a little bit. Okay. This is it. This is it. Now the student would keep walking maybe till here. I don't know. To which point. So let's say this is 450 Newton. This is the 150 Newton. It was exactly in the middle. As we said, this was 1.5 meter and this was 1.5 meter. And this is half meter and this is half meter, right? So he is walking from this point. We put another pillar. To this distance. This is D. Now you have to take, I want to find D. Now you have to take the moment around what you decide. You can take the moment around A, around B. It's better to take it around A. Why? Because it's cancelled. So if it's cancelled, خلاص, I don't need to do this. So let's take it around A. B, already it has no moment, so I will erase it because it's not important. So this is the drawing. Now, we have only two forces that are important. There is a force here, but it's not important because it has no moment. Here we have 450, here we have 150. And now what do we want to do? We want to make moment clockwise equal moment anti-clockwise. Take the moment around point A again. So this force, 450, times this distance from here to here, let me call it point X, times X, should equal 150 times which distance from here to the pivot, 1.5. So do the calculation for me, please, and somebody give me the answer. What is X? X will be 150 times 1.5 over 450, 0.5. Oh, 0.5 meter. So, yeah, he needs to stand up here at the edge exactly. It will flip. Before the edge, it will not. I know this distance is only 0.5. So now, so the distance, the moved distance is how much? Can you tell me? When he was half meter to the right, now he has to be half meter to the left. So that the distance is 1.0 meter. So that if he walks this distance, then the header will flip. Okay? Do you have a question? Yes. تفضل. هلا I did not use it. I did not use it here. بس احنا up equals down. Here we have RA, here we have RB. RA plus RB equals 600. مظبوط? Since he said it's tilting around A, then B will not be. Imagine high A. It's tilting around it, so it's moving like this. It will flip now. So it's losing contact with B. So B has no force. This means RA plus RB equal to 600. Now this is 0. So RA is equal to 600. Although when I used it around A, I just cancelled even the moment of A. Yani I don't care about it. But if you want to take the moment around this point, then you have to take RA into consideration. So I cancelled it. Okay? Clear هلا عبد؟ Okay. You have question حبايبي حدا عنده أي سؤال؟ Maha, if you have a question, just send me on WhatsApp. لأنه I think you can't talk here. Okay. Send me via WhatsApp if you want any question. Now this is question number 1. Let me show you another question. In fact, moment is one of the nice but challenging questions in physics. It's nice, I like it, but it's also challenging. Let me do it this way. Here we have question 2. Here we have rod. Uniform rod again. The weight of this uniform rod is 80 Newton. It is hanging by a rope, which it's connected to this point, and it is hanging like this. where this angle is 30 degrees, and at the other end there is just only a hinge. Hinge means mafsal, just like the one that we have it on the door. So imagine that it's just like a pivot, just like a peg here. So it's falling down, but because it is pulled up this way, so it's not falling down. Now this is a hinge. This distance from here to here, 2 meters, this distance 2 meters. Okay. If I'm asking you, what are the forces acting on this rod? Please try, somebody tries. What are the forces acting on this rod? Weight, okay. Tension, 100%, but not enough. There is a third force here. Do you know from where we get it? From where we get it? From the hinge. The hinge produces a normal reaction force. And a normal reaction, what is the direction of it? It's hard to tell from the beginning. At the end of this question, I will ask you to find it. But so far, it's hard to find. طب أستاذ شو بدي أعمل? There is a force here that we can tell where is it. So I don't want to draw it, because if I draw it, maybe I'll draw it wrong. Although I know how to draw it, but I will not. So the question is, A, find the force of tension. Find the tension force in rod. Okay. Find the tension force in rod. We can't find the tension in rod directly this way. We can't. Again, لأنه there is a third force here unknown. The resultant force equals 0. We can't say up equal down, because there is unknown upward force here and unknown upward force here, two unknown forces. With no information there, it's hard. So says what you will do, I will jump to condition number 2 for equilibrium. طبعا the question must say the rod is balanced or the rod is in equilibrium. I'm skipping this because I do assume that all of these are in equilibrium. No. So I will jump to condition number 2. Resultant moment should equal 0. How resultant moment should equal 0? This way. Resultant moment equal to 0. You have to take moment around 1 point. Since here there is a force. A force and 2 components, but there is a force here which is unknown. So I will take the moment around the hinge. Take moment around or about the hinge. So whatever the force is here will be cancelled. So this is the pivot. Here is the pivot. What are the forces there? We have 280 times this distance from here to here is only 2. Should equal this force, which is tension, times 4 times sine. Sine, which angle do we want to take? Now remember, we want to take the angle between the distance and the force. Here is the force. Here is the distance. So this is the angle. How much is this angle now? This is 30. So this is 30. So this angle is 150. So sine 150. Sine 150, in fact, is the same as sine 30. Try it, please. Make sine 150. Is it half? Yes. Sine 150, half. Make sure that your calculator is on. Yes. So same as sine 30. It's the same. So either you take this one or this one, it's the same. So sine 150, which is half. So half times t is in t, 2t equal 280 times 2 is in t equal 280 Newton. Okay. So t here by chance طلعت 280 Newton. طبعا not necessarily to be 280 Newton. If the angle was different than 30, everything will be changed. But this is just only an example. So this is A. Now, let me write B. B, find the force of the hinge on the rod. Find the force from the hinge on the rod. Now here, because we don't know what are the values there, so what we will do, we will assume that there are two forces, one horizontal, one vertical, and find the components of this force. اوكي راح يرن الجرس يا شباب، خليكم طولوا بالكم معي، اوريدي تاخرت منها، لما تتاخر ما هيك بصير. فهير we have T, here we have T horizontal, here we have T vertical. Right? Since there is a horizontal force here, it's impossible for the rod to be in equilibrium unless if there is a reaction here, R horizontal. How much R horizontal is the same as T horizontal? Right? Isn't? Also, T vertical, here we have 280. Can you do it for me? T vertical, how much T vertical? T vertical is 280 times 200 T vertical equal 280 sine 30. 280 sine 30, the answer is 140 Newton. So T vertical is 100. So here we have 140. Here we have 280. They are not in balance unless if there is another force here, R vertical. So R vertical plus T vertical should equal to 280. So R vertical is 140 Newton. This is R vertical. And I did not find the final answer. This is only the vertical solution. Now R horizontal is equal to T horizontal. T horizontal زي ما اتفقنا هي 280 cosine 30. Do it please on calculator and tell me the answer. 280 times cosine 30. How much? 280 times cosine 30. 245? 242. طبعا rounded, I know. Just keep it like this. Now you know that R horizontal is 242 Newton. And you know that R vertical is 140. Now I don't want not this and not this. I want their resultant. So this is the resultant. R. How do we find R? Simply, R equal. So R equal. Please do it on calculator equal not 242. Please do it answer squared plus 140 squared under square root. And before you tell me the answer, I will tell it to you. 280. مظبوط؟ Yes. How did you know, Ustaz? أنا بالنسبة لي I know that this is symmetric. If this is 280, طبعا not necessarily everything to be 280. But if this is 280, if here we have 150, then here we have 150 because they are symmetric. Because same distance, same everything. But it should be R300 and this angle should be 30 degrees. So theta equal tan inverse اللي هو RV اللي هو 140 over 242. If you do it on calculator with no rounding, it will be 30 degrees sharp. So this is enough for today. This is what we did. I wish you all the best, Jama'a. I will send you a homework today at night. I will send you homework trying to solve some questions from moment. You will not find moment in the past papers. So now I want to try to find it. I will send them on the group. Momentum, nobody told me that he already did it. If you did it, please just let me know that you did it. I will send the answers of momentum today. I already did them from yesterday, so I will send them today. Because now I have a class, so we will continue like this. After a little bit, after 2 hours, I will send it to you. What I'm asking you, يا جماعة, tomorrow at 2 o'clock again, the same time. Is it okay? I am happy with what we did. We did a good job today. الحقيقة it's more than 1 hour and a half. هذا الدرس بياخد double in the class. Now it took from us 1 hour, so it's good. So tomorrow at 1 o'clock, at 2 o'clock, sorry, same as today. I wish that everybody will be ready, and be ready, please prepare your device before you start. Okay? يلا يعطيكم العافية. سلامات. تقدر you can leave.